So let's continue looking in section 1 and let's talk about sets. And when we talk about sets, we've got some good vocabulary. First of all, let's look at roster notation. And this is how you've given answers before in Algebra 2. So we could say X is the set that contains 0, 1, and 2. So we're going to use roster notation, not set builder or interval here, but roster notation where we're given a finite list. And yes, this is finite. If we get into the set of all real numbers, that of course is an infinite set. But roster notation allows us to denote a finite set. So union versus intersection. So union is symbolized with the big funky U, and intersection is symbolized with the upside down big funky U. Union represents the conjunction or. An intersection of two sets is when we'll be using the word and. So if we think about a verbal example of union, we can say that everyone is either a boy or a girl. You fit into one category or the other. If we're talking about the intersection and, it's going to be something that two sets have in common. And we're going to see this played out on the next page with the next example. So here we've got sets A and B. Set A contains the elements 7, 8, 9, 10, and 11. Set B only contains 6, 8, 10, and 12. A good way to see the union and the intersection of two sets is to put the numbers into a Venn diagram. So V-E-N-N, Venn diagram, German mathematician from long ago. So set A is going to be in this circle. Set B is going to be in this circle. And the box actually represents the universal set. So we'll get into that a little bit more in class. But first of all, we need to look, the first thing we want to do is find what elements do both sets have in common. So it looks like set A has an 8, set B has an 8. Set A has a 10, set B has a 10. So 8 and 10 are going to be in this overlap, and that is the intersection. The intersection is the overlap. So 8 and 10 are right in there in the overlap. And here's the rest of set A. 7 belongs to set A, 9 belongs to set A, and 11 belongs to set A. Set B also contains 6 and 12. So we can write that in terms of an intersection. And here is, let's put it on a separate sheet of paper here. So here we go. If we were to say A intersect B, remember that's the big upside down funky U. It represents an intersection. What elements exist in set A and set B at the same time? In roster notation, and normally we put our roster notation in numerical order, it would be the elements 8 and 10. That's the intersection of A and B. What elements exist in A and B at the same time? Now let's go union. A union B. Remember, union represents the conjunction or. What elements exist in set A or set B? So the union, think about it as the marriage of these two sets. So that means all of the elements in both sets at the same time, the elements exist in one or the other, are going to make the union. And we can see the union here because the union is everything, even the ones that are in the overlap. That's the union of the two sets. So 6, 7, 8, 9, 10, 11, and 12 are in the union. The intersection is what they have in common. The union is all the elements that exist in one set or the other. So even though 8 and 10 are in the intersection, we still only write them one time in the roster notation. That is the union. So union versus intersection. Let's do it again. This time we've got sets X, Y, and Z. So X, 0, 2, 4, 6, 8, 10, 12. Set Y, 0, 3, 6, 9, 12, 15. Set Z, 5, 7, 11, 13. So before we draw anything in the box that is going to be the Venn diagram, is there an intersection of X, Y, and Z? So X intersect Y intersect Z. So is there an element that's in common in all three? So set X and Y both have a 6 and both have a 12. But does set Z have a 6 or a 12? No. And it appears that the intersection of X, Y, and Z is empty. That set is empty. Why? Because there is not an element that all three sets have in common. But remember, there was an intersection of X and Y. So X intersect Y does have some elements in it. 6 and 12. 6 and 12. So the intersection of X and Y is only 6 and 12. So when we're drawing our circles here, here's X, here's Y, and here's Z. I'm putting Z all the way over here because there's no overlap with set Z with X or Y. There is an overlap for X and Y, and that's that intersection right there. So 6 and 12 are going in the intersection. And 0. I'm about to miss 0. Right there. 0, 6, or 12. We'll squish 0 right in the middle. So 0, 6, 12. That's the intersection of X and Y. Okay, the rest of X. So we got 0. We need 2. We need 4. We got 6. Here's 8. Here's 10. There's 12. Set Y. We got our 0, here's our 3, there's our 6, here's our 9, here's our 12, here's our 15. And then finally, set Z contains 5, 7, 11, and 13. So, what do we have here? Let's see if we can squish a union right over here. X, union, Y. Remember, X union Y are all the elements that exist in X or Y at the same time, one or the other. So that's going to be all of the numbers, even the ones that are in the intersection. So 0, 2, 3, 4, 6, 8, 9, 10, 12, and 15. That would be the intersection of, the union, X, union, Y, union, or, there we go, X, union, Y, 0, 2, 3, 4, 6, 8, 9, 10, 12, 15. One last one, just to be certain, even though apparently I'm ready for the weekend. Let's do Y, union, Z. What elements exist in Y or Z? Remember, one or the other. All the elements exist in one or the other. So that would be 0, 3, 5, 7, we'll put 6 right there. Normally we want them in order. So 7, 6, 9, 11, 12, 13, and 15. So intersection and union or.